I start. Welcome everyone. This is the second lecture of the ICIEV-IVPR lecture series. Today our keynote speaker is Professor Sozo Inoue. He's from Kyushu Institute of Technology and he is the CTO of startup AutoCare. Today's lecture is on smartphone-based human activity recognition application to nursing big data, and he's working on these kind of things for a long period, and a very smart and nice person. And you will be glad to know that his lab is full of Bangladeshi researchers. Already one graduated, and at this moment there are one postdoc and 4 students from Bangladesh and other countries as well. And Professor Sozo is the general chair of the International Conference on Activity and Behavior Computing, which we call as ABC. So he is the founder chair, and next year it will be held in Bangkok. So we hope that some of you will able to attend. And he was the main organizer of ICIEV-IVPR conference this year in Kyushu, and 2018 in Kyushu as well. I hope that some of you already met him in person, and many of you know him, and he was the first speaker of our first international conference on informatics, electronics and vision, ICIV 2012 in Bangladesh. So without any further delay, I would like to request Professor Sozo Inoue to start his speech. And when he will finish, we'll take question and answers. So we have participants from all over the world, and we hope that we'll enjoy your talk. Thank you so much. Please enjoy.
Thank you very much, Professor Ahad, for the very nice introduction of me. So, can you hear me? You can hear me, right?
Yes, nice.
Okay, let me start. So today I have several slides, but basically I was not sure that to what kind of people audience I should prepare. So I prepared somehow. Including some of the overview of our research, and also if there is some of the more specific questions or some comments. So I'm also welcome to receive this kind of the comments or the discussions. So feel free to interrupt me during my talk. So so you can stop me anytime for any topics. Okay. So my name is Sozo Inoue, and as Professor Ahad introduced, I'm right now in QTech, Japan, and also a CTO at the one startup company. But it is also related to our project, so I will also introduce these kind of things later on. So the outline of this talk is, firstly, I want to introduce the human activity recognition. So maybe most of you or many of you guys already know about this, but I'll very briefly introduce. And the second thing is that using the human activity recognition or combining with some other data as medical data or something like that, what we can do is briefly overview. And the third thing is that the project, the now ongoing project, but also applied for the more and more application-oriented, or the application to the more realistic fields. So this is the third topic. Okay. So what is this? So this is a very brief introduction of our university, and I hope that you can see the video. will skip some of the parts, but basically we are in the from the school of we have 3 campuses, and oh, okay, that's good. Okay, this was some of the introduction of the campuses and some of the researches out here. Okay, so because we are from the Institute of Technology, we have some of the also the mainly we have the students and the faculties from the engineering. Okay, among them, so our lab are mainly interested in the in one this is a one page slide to introduce our lab, but mainly we are working on the human activity recognition and also applying to the bigger data. So this is a very simple introduction of our lab. But as a keyword, we are saying that the human activity and medical and nursing care applications, such as things are the keyword of our lab. And we have many students. And right now, I think that we have 7 countries or something to students. So it's very international right now. So, okay. So this next is our lab's introduction. So it is not directly related to the, no, it's related, but it is a very, I think it is a very good video to introduce our research activities. So I will just briefly show you. Okay, so it was an introduction video of our lab, but the last part of the activity is almost canceled in this year because of the corona. But we are very enjoying the research and the research activities as like a family. And yeah, I think that I hope that the students can enjoy the lab's activity. Okay, so let's go into the details. And firstly, that the human activity recognition is defined as the to recognize the human's activity or the translate the human's activity from sensors to the activities. Okay, so of course we use machine learning, but this is as you already see. So this is one of the example that she only has a smartphone on the chest pocket, and we are detecting the activities of her in real time, what she is doing, taking and calling and taking and something like that. So this is only using the smartphone's 3D accelerometer. And but you may know that you may find if you have tried some of the activity recognition or some of the similar things, then you may find that these activities are very simple. I mean, simple means that putting or walking or this kind of things is very basic activities. But if we want to apply for example, like this kind of nursing activities or nurses, so the things are not so simple, or the problems are not so simple. So this is one of our lab's challenge. So okay, so and another challenge is that because we are relying on the machine learning basically. So if we don't have data, then we cannot do anything. So this is another challenge, because if you want to, for example, if you want to realize the human activity recognition or the nursing activity recognition or any other professional activity recognition, then you need data from that kind of the application domain. So it is not so simple. So this is one of the research challenge or the interest of our laboratory. So we are also holding some of the workshops of Human Activity Sensing Consortium, and also we are holding the conference, international conference on activity and behavior computing. And some of you may already know that we are holding some of the activity recognition challenge or the competition over there. So if you are already know, so thank you very much about this. So, and let's go to the overview that about what we can do using machine learning or the human activity recognition. So basically, so I like to think very simple. So when I was asked that what you can do by AI, for example, then I'm answering that we can do three things, basically from supervised machine learning. And the first one is that to estimate the unknown values. And the second one is to predict the future values. And the third one is to analyze the causalities or the causes or the correlation. So I would like to explain one of them, each of them. And but basically that as a background, we can say that in Japan, especially in Japan, we are very advanced country for getting older. So this means that we need a very much, we have the very much social challenges. But anyway, so what we can do for this kind of problems? So one first example is the estimation. The estimation means that the human activity recognition itself is one of the estimation. Estimation means the recognition or the, yes, something like that. And we tried the activity recognition for the nursing nursing activities in hospital, and we tried for to collect the labeled data for 2 weeks and unlabeled data for 2 years. And we applied several approaches to improve the activity recognition. But this was very interesting because we used some of the information which could not be used if you only collected from the lab's environment, because we used some of the very realistic data, such as time in a day. So time in a day means that if you know that, for example, if it is 12 p.m. At noon, then it becomes higher probability that you are you are having meals or you are having lunch, right? So this kind of the global information is also found that it helps to improve the accuracy of the human activity recognition. And if we have the data set from the lab, so normally we don't have the whole day's data set from the lab's data, so which could not be evaluated or proved that it is useful. So that was one finding from them. Okay, so the next is we also tried in home settings, and we tried to apply several transfer learning among the households. And yes, so this, I'm not going to the very details of the each research, but I'd like to say that this is one of the example of the estimation from something. And the third one is that also this is introduced later on, but we also tried to apply this technology to the elderly care homes. Okay, I will talk about this later on. And second one is a prediction. Prediction means that the future prediction. So basically, the technology is almost the same as the number one of the estimation, because that we can, as a machine learning or the supervised machine learning, we assume that we need a data, but from the data, training data, we need two things basically. First one is the input. Second one is output. And the input is basically said as the explanatory variable, and the output is called as the objective variables. So from this kind of pairs of the data set, we can apply the machine learning, supervised machine learning. But if we make the output or the objective variables as the future values, not we just organize the data, we arrange the data to not to use the current information, current input and current output, but we use it as a current input and the future output. Then we can train the model to predict the future. So some of the examples for the hospital or the hospital application is that the first one is that we applied some IoT sensors to the one floor of the hospital, and we asked each nurses to attach the infrared infrared signal receiver, and we attached the infrared beacon to each side of the bed. So we attached like this, and we received, so each beacon has an ID, and the ID has some information of the location or the correspondence to the bed. And if you get the medical records from the hospital, then of course that the medical records includes the patient information, and also the information about which bed each patient are located. So by this kind of way, we can link the patient and the beacon and nurses. Okay, so we can have this kind of the rich data, and by using this kind of the data, at first we predicted the busyness of nurses of the next day from the input of the today's nursing activity or the patient status. Then we could demonstrated that we can predict the busyness of the next workload of the each nurse for each activity for the next day. So this is one of the example. And the second, well, we also have several other application, but sorry, I skipped one slide. But another application was that we also predicted the future of patient, which means that whether the patient can be discharged in a very short time or not, or whether the patient can be discharged in a very good health status or a good ADL level. So this was also tried to predict it. So I forgot to insert this slide about the slide for the result, but we also tried these kind of things. So this was the example of the future prediction. And the third application example is the causality analysis. So the causality analysis means that this is the example from the same example from the previous slide, but we also focus. We are also highlighted in some magazines for the nursing cares. But what we did there, sorry, oh, I had skipped several slides. But what we did there was that we also investigated some of the causes which led to the future of the patient. And we found that some of the important factors or the unimportant factors, and some of the, okay, so let me explain a little bit more. And in this analysis, the input was the nursing activities, okay, or the length of the nursing activity, each types of the nursing activities, and the output or the outcomes was the patient's future. Okay, so normally in the step 2, we did a prediction of the patient's status, but as well, we also analyzed the causes or the which activity led to the good effect or the good prediction of the patient outcome. Then we could find some of the important activities and some of the unimportant activities. And among the unimportant activities, we had something like preparing the meals, or giving away the trashes, or something like how to say, the activities which is not directly related to the nursing activities, what were included in this kind of the unimportant activities. So we also discussed with the nurses, and the nurses also agreed to that this is not important for patients. So they reduced this kind of activities or delegated to these activities to the other assistants. So this was one example of the causality analysis, and this is very much related to the somehow something to say, how to say, which is called explainable AI. So AI needs to explain the reason. So this is one of the primitive example of the explainable AI, I think. Okay, and another example is that we did a text mining for the caregiving dataset. So they have some of the text data for the accident report in the elderly care homes. So because the elderly people are very much needs a care, or somehow they have the accident, such as falling down or something, then it will be very much terrible for them sometimes, because they could never get up or live in a very active way, or they have to stay on the bed for the rest of his or her life. So we want to avoid this kind of situation, and we try to analyze the text or the text accident reports from 80 facilities in Japan. And we also found from the some of the data set, we found that some of the patterns are also foundable by the machine learning. And one of the two interesting results was that we analyzed in which situation the accident leads to the very much terrible situations. And we found two patterns. One was that the cafeteria and the mismedication. This is after the lunchtime. They sometimes, if they have some accident, then it leads to the very much terrible, serious problem, serious accident. And the other pattern was that the falling down at some of the places in the morning. But this is important because to note that this is not the time of the falling down, but the time of the staff found this kind of accident. So this was some of the text mining example of some of the how to say causality or the correlation analysis about the severe accident. But we can use this kind of data for preventing in a way that we can expect some of the higher possibility of the severe accident, so we can watch more intensively about when the elder people are in this situation. So this is one of the another example of the causality analysis. So yeah, talking about this kind of applications. So one of the key questions for me is that we have so many research papers in activity recognition, but if we apply to the field, so there will be very much challenges, especially if we use machine learning technologies. Okay. So, and we are also, so that's why we are also trying to do some more larger project for the applying the IoT or the some systems for the elder people. And this is a number of the papers that you search as activity recognition in Google Scholar. So it is already to so many, but we yeah, we found, or we have to say that how many numbers of applications are already applied for the real life. So we should say to the question from the high school students that we have to say 0. So which means, so for the simple activities, it's okay. But for the higher level or the general activities or the complex activities, so it is not still in the status of the widely spread. So this is the one of the challenges of our lab. And we tried in the one of the North Korea facilities of 4 floors, 4 months, 20 residents, 27 staffs, and so many hours, so many activity ladders and the care details. So we collected this kind of data. And in this experience, so we found that many challenges are there, and also some hopes for some good sign for the applying the activity recognition. Okay, so the first decision to apply these kind of technologies to the nursing care homes, that was that first that they spend the almost 1 hour for recording every day in handwriting per person, for every person. And other facilities are found that they are doing much more, like 30 minutes, every 30 minutes for 24 hours. So they want to reduce this kind of the boring activities. So, and the activity of nurses are highly, so from our experience for the activity recognition, we found that the activity recognition or the activities should be highly user dependent. Even in the same activity class, the real sensor behavior is very much different person to person, or the environment to environment, or place to place. And so we developed a system for self-annotation of nursing activities. And but other than the self-annotation, we can have several options like the observers, employing observers, but it is costly, and the offline labeling by video, but very much costly, and the privacy problems are there. So we decided to develop the system for integrating both of them. So, but it was not so simple, because firstly, uh, the nursing staff has sometimes very low, little IT skills. So this kind of the senior people is also the staff. And the most of the caregivers are not good at the IT skills. So this was the first challenge. And no money. No money means that generally in Japan, we are having the increasing rate of the elder people. So if we have the very much good system, but if it is very expensive, then it doesn't work in Japan anyway. So this is the second program. So we decided to use the local smartphone sensors. And for the also the third challenge was there's very little environment to have the internet. So if you see this graph, that and the internet usage ratio by age is very high, very low in the elder people. So it is, we can estimate that in this kind of elder care homes, so we have no internet or little internet connection. So we need to develop some system to work offline. So as for the activity recognition, we have the list of the complex activities, of course, such as vital checking, meal, medication, oral care, expression, or this kind of the assistance. So these are not simple as just walking or sitting or something like that. Okay. And also, we found the imbalances. Imbalances means that some of the activities happen very much time, a lot of times, but some are very rare, happen very rare. For example, this kind of accident itself is very much rare. And in general, the machine learning, supervised machine learning is not so durable for the such imbalances. Okay. So, and also we found the incorrect label timestamps. So this will be shown afterwards. And there are also the overlaps of the labels. Okay. So,
パット交換とかする人は大体3行ぐらいは手書きで書いてるんですよ。それも根本的にポンポンこういう感じでポンポンパット交換ポンポンでもうチェックで。
We have the three columns. We can just simply choose the types of activities and the target people and the record itself. So you can see the record, this video.
パット交換とかする人は大体3行ぐらいは手書きで書いてるんですよ。それも根本的にポンポンこういう感じでパット交換ポンポンでもうチェックで記録が全部これに入ったからパット交換とかする人は大体3行ぐらい。
And also, sorry. This button is very interesting because they can also record the starting time and the finishing time. So we have there are so many applications to record this kind of the activities, but most of them are not so accurate for the timestamps basically, and some of them are not able to record the start and time, start and finish time. Okay. And we developed the cloud system to collect this kind of data set, and also the sensor data is also collected as a background task of the smartphone. Sensor data means accelerometer mainly. Okay. Okay, so let's see the data. So at first we can show that the imbalanceness, how the imbalanceness happened. Okay, so as for the activity-wise, we have the imbalanceness because this activity has so many times, but these are very small. Okay, and as for the resident-wise, so number of levels are very different. Okay, some of the people are very much needed care, and others are not so much. And day-wise, every day they have not so much difference. And also the time of the day-wise, they have the imbalances. So these kind of imbalances are not considered in the simple activity recognition in lab settings. But if you try to apply for the realistic settings, then you can easily face this kind of problems. Okay, so how about timestamps? So that did they label in the end of the day at once or something like that? But we can see that the time of the day wise, the labels timestamps vary in a large variance. So it's no. And once the label input delayed, which means that we offered this kind of functions, start and doing and stop, but they can be also the nurses or the staff might have recorded these activities after they do the activities. So we did an inquiry, then then they answered like they did it the one or two timings of the one or number two, so which means that yes. And when we look at the durations of the activities, then the one they so it was recorded as very short times than the real activity duration. So we found this kind of the challenges. So it means that even using our system, that the labeling is not so correct. So we try to also evaluate the activity recognition accuracies by extending the timestamps, starting looking at this based on this observation. We extend the timestamps, then we found that some of the activity recognition activity accuracies are improved. Okay, so this is one of the results. But I will skip this kind of parts because this is going to too much details. Anyway. Okay. So we did a lot of analysis on this kind of things. And but I would like to show the overall effect of using our system. So as I said, that they used 16 minutes for recording the nursing records, but it was done by handwriting. And when we introduce the IT system, then we can reduce to 34 minutes. And after we introduce the activity recognition, then they could be reduced to 23 minutes. So which means that our system can suggest the input of the activities before they input by using activity recognition, which means that we can suggest that, oh, you did these activities, right? And then they can, if it is correct, they can just tap it. And if it is not correct, then they can remove it. So this kind of time is measured, then it was reduced to this kind of time. So it is very small improvement for one person per day. But if you consider 2 million staffs are there as caregivers already, then it becomes non-negligible effect. And also we apply the near future prediction in the same facilities. And we applied the prediction of the whether or when each activity will happen in today or the tomorrow or something like that. So, and also in this kind of the application, we were said that these three activities were very important. For example, excretion or the daytime user response, or this is, a nighttime user response, which means that it is not a regular activities, but this is a, how to say, request-based service. But this kind of request-based service is very cumbersome for the staff. So if we can predict these kind of things will happen, then they can prepare for this activity. So this will be effective for them to predict. Okay, so let's go to the wrap up of my talk. And I firstly introduced the human activity recognition technologies, and also we talked about some of the challenges. And using the secondly, I introduced some of the application scenario for the machine learning, mainly divided to three parts. And but finally, I introduced some the project, big project for the application for IoT for elders, or the application of activity recognition for caregiving facilities. And finally, we created a startup which is called AutoCare, and we are also trying to deploy this system to the many facilities in Japan, or the caregiving companies in Japan right now. And we hope that we can collect big data from the application. Okay, thank you very much. Ahara-san, so you are the chair, right? So I'll give the
Yes,
microphone back
thank
to
you
you.
so much for your excellent presentation. So we are welcoming the participants for you questions or comments. Feel free to ask any questions. If you are shy, then you can type. Please. So you can unmute, or you just, raise hand to ask any questions.
Hello, sir. I'm Mohammad Sadman Siraj from University of Dhaka, Bangladesh. I'm a graduate student now at the moment. Sir, I had one particular question from your slides. A part is there where it mentions that for prediction and estimation tasks in machine learning, we use sometimes 1% leave out cross validation. But from my experience in nurse care challenge data, it's very difficult sometimes to do 1% leave out cross validation, because sometimes you have lab data and field data, so you are not always certain whether how to make a combination of them. Again, sometimes all the subjects do not have all the data or all the activities. So in that case, how do we perform 1% leave out cross validation? Because it is not always possible that all the subjects will have all the activity data. So if we leave out 1%, we are missing some of the data, and so we cannot cross validate in that case. So what is an alternative for this?
Thank you very much. So at first, thank you very much also for participating in the challenges already. And yeah, I think you did a very hard work, and we are very much thankful for this kind of contribution. And yes, yeah, maybe you are talking about this year's challenge, right?
Yes, sir.
So we, how to say, we wanted to show, share some of the difficulty of doing the activity recognition for the realistic data set. So in that challenge, we included the data set from the lab and also the data set from the field. So it was not from the hospital, but from the caregiving facilities. But this is, I think that as I said, as I showed in some slides, that lab and the fields are quite different sometimes. And not only, yeah, if we say they're quite different in the machine learning context, normally it is very popular in the transfer learning scenario context. The transfer learning means that you have to train in some domain. The data set comes from some domain, but you have to apply it in a different domain, which means that data sets natures or the characteristics are different. Okay, but normally when we talk about the transfer learning, then we just assume that the distribution or the characteristics of the data sets are different. But so it means that the probability distribution or the various data distribution are different. But in reality, the more difficult things happen, such as that you don't have any data set or any samples for specific activity classes. So this is first. And also, sometimes there might be so much difference between person. Yeah, something like this kind of the difference will happen. So I think that this is not only the case for the cross-validation, but the cross-validation is definitely needed for training, getting the better accuracy in the test data set. So we cannot get rid of the cross-validation, but yes. So I think that we need to consider in two steps. Okay, basically. So first step is to apply the transfer learning, and the second step is to to consider what we can do when it happens for example, the some of the classes doesn't appear in the training dataset. So you may know that there is some techniques which is called zero-shot learning. So zero-shot learning is a technique to um, estimate the new class activities, new means, which doesn't appear in the training dataset. So in general, we can say that we have to tackle with the transfer learning and the zero-shot learning. But both of them are not still perfect. So we think that we have this uh, many more challenges about that. And one more thing is that we can also consider some different scenarios for the application. Of course, in challenge, it is already defined. But for example, in realistic settings, we can think like in two ways. So the one way is that we can get the training data from the same person. The other way is that we assume that we cannot get the data from the same person. So in the challenge, it was in the former scenario. So it was very tough. But in reality, if you can collect the training data from the target user, then the things will be a little bit easier, in my opinion.
Thank you, sir. Thank you. I understand that part. Sir, one more question is that there are multiple subjects. So, what is the best way to make the model or system subject independent? We can make it position independent using several techniques, but what are some established ways to do subject independence? Or should we just use transfer learning there as well for training the
Yeah,
model
I
on
think
different
it is.
subjects?
Yeah, in my opinion, this is the one of the transfer learning application.
Okay.
So we can basically try the transfer learning, but we may also be able to use some of the, some of the specific technology for the subject-wise difference. So this is, in general, we can compare with rule-based AI and machine learning-based AI.
Yes, sir.
So we can try, in general, the mixture or the integrated way of this kind of thing. Basically, it is a transfer learning program.
Thank you. Thank you, sir.
Yeah, so we have a few more questions in the chat box. It
Oh,
would be nice if you can ask, but anyway, I just repeat. I mean, Mr. Rafi, he said, how can I start with activity recognition?
sorry?
How
What
can
kind of
I start with activity recognition?
start what? Start
Maybe research.
using. Oh, okay, okay. So I will comment. I suggest that yeah, there are so many papers or there are so many programs or there's so many tools. So I think that as a researchers we can easily start. But one possibility is that you can join the challenge that we are organizing continuously. Then you can know that how it is difficult or something like that. So first of the challenge is to collect the data, but we can provide the data. So we can start from trying the data analysis or machine learning. So I think that, in the machine learning field, we have so many data sets to try easily, like the handwriting data set or the image recognition data set or something like that. So if you have the data of sensor data, then it will be easier to start.
Okay, so another recommendation is that you can buy our book or my book, like IoT sensor based activity recognition. It is,
Yeah.
I mean, that book has all the 10 chapters guidelines on how to do, but I recommend that you just, if you are very new, then just get a top class review or survey paper and then see how you can progress. And if you have any questions, you can ask later on by email. Anyway, the next question is from Arafat Rahman. He wrote, sometimes subjects start an activity and forget to stop the watch. So the activity duration becomes mistakenly big. How to overcome this challenge? And Arafat participated the challenges at ABC and not ABC, I mean at UBCom. Yeah.
Thank you very much for participating in the challenge again. And yes, this kind of the challenge or the problem is, I think that it can be classified as incorrect timestamps of the labels. Okay, so this means that we we normally trust the labels or the training labels. We trust the training data set, but in this kind of the data set, sometimes the training data is wrong. So this is interesting part, and especially if the times, especially for the timestamps. So it is very difficult to collect the very correct activities segment or the timestamps of the activity labels, because this is done by the human also. Okay, and if we try to collect a larger data set, then that happens a lot of times. And there are also several technical solutions for that. So I know that we in 1916, I think 1916, in Mobiquita's conference, we proposed this one technology to fix the timestamps based on the accuracy of the recognition performance, accuracy of the recognition, human activity recognition. So which means that we tried to find the best timestamps to maximize the accuracy, and then with the assumption that, that if we have the good accuracy or the correct timestamp, then we should have the good performance accuracy. And the similar paper also published in last year, UBCom, IMWAT, or the UBCom. So you can also check, it was from Georgia Tech, and you can also check this kind of the paper. Then you can find some of the smart approach to solve this kind of problem. It is not perfect, always perfect, but we can apply some of them. Okay.
Okay, the next question is from Tahia Tazin. If there is so much class imbalance, then what is the best option to handle data?
I'm not still sure what to do about this. So, but I know that this is not the specific problem in activity recognition, but the general problem in machine learning, right? And if you check some of the papers for class imbalance problem, then you can find some of the papers of overcoming, or the, how to say, recovering the imbalances, such as by such as resampling or similar technology. Okay, but I personally think that it is not always good to do this kind of things, because in realistic data set, the test data is also imbalanced, right? So if you prepare the training data set which is balanced, and then you trained it, then the model can be generated so to be good at the balanced data set. But if you use this, when you use this model, then the test data is imbalanced again. So I don't know how to deal with these kind of things. And if you know some of the good solution, then it will be a very good paper, I think.
Okay, the next
Okay.
question is from Sania Jahan. What is your thought on data representation that best describes the spatio-temporal information?
That is very much a very interesting problem, question, a very good question, I think. Because in history, there are so many researchers has worked on spatio-temporal information or spatio-temporal database, spatio-temporal signal processing or something like that. So I think that, that there is no optimal data representation. And also we need to consider how the data set are used, how the data are used in the real case. So for example, if you want to, how to say, to use in streaming way, then there should be some of a good best representation for streaming. So of course it will be how to say, it will be affected by the real timeness or the time of the time window, size of the time window. And but if you want to archive the data, spatial-temporal data, and if you want to use it 100 years after, then maybe the representation should be different. So this is, I think this kind of research is on the database community, such as KDB or the VLDB or something like that. So if you check the papers from there, then there will be so many papers about this.
Okay, any other questions from others? So I have one more question from Dr. Supradeep Ghosh, I guess. Thank you for your speech. You have activity recognition in varied domains. What are the observations effects of data processing for activity recognition? What type of noise filter have you used? So one is the data processing issue, another one is filtering issue.
Okay, so
I wanted to ask a question, sir.
Okay, after this, okay? Okay, so you reply this question and then another, yes.
Okay. I will answer this question, of course. And yes, so I'm not sure, but I don't have the exact answer, but basically that when we do the activity recognition for big data, so we tend to take the time window in a larger size, like 1 minute or something like that, because of the reason of the computation cost or something. So in that case, then the noise or the noise or some of the irregular signals will be eliminated, tends to be eliminated. So that doesn't have to be a very big problem. But if you use it for the more accurate or precise activity recognition, then this becomes somehow challenging. But one of the things is that one of the interesting research what we did before is that it was done by one student, Tahira Hossain, in our laboratory. But she was thinking that we assume the in real situation we have noisy data, but in the training data we have, or the lab data, we have a very clean data without noise. So if this kind of the gap exists in the training and test data, then the accuracy goes down. So we proposed a method to tune the noise level of the training data to fit to the test data. Then we can improve the activity recognition accuracy. So that was awarded as the best paper at ICIEV 2018, I think. So this was also the interesting approach. So I'd like to just introduce this idea. Okay.
Okay, so one more question, please. Ask, you raise the hand. Your name is not mentioned, so 1KL7. Please ask your question. Maybe he is out somehow. Network problem. Yeah, because he was supposed to ask a question. Okay. Any other questions or comments from anyone? We can see some experts as well. Okay, so if no questions, we can wait. But I have one question. Like, I mean, we know that activity recognition, healthcare, this kind of stuffs are related to data science and machine learning, and so on. And in Japan, the demand is extremely high. What about the job fields in Japan? Because I know that one of your students, Shafiqul, got the job in Tokyo after graduation from your lab without learning any Japanese. So do you think that from overseas, someone can apply for a job with good skill and get a job in the startup companies or similar kind of companies? And what about your auto care company? Can we have some kind of internship issues and others? So would you please give us something more on that? Because there are, I mean, good amount of young researchers here.
Okay. So I think Shafiqul can say something if he's here. But anyway, so
So you can share, no problem.
Oh, so can you introduce yourself a little bit and can you share your experience right now?
Okay, so actually I graduated from Institute of Information Technology, Dhaka University in 2012, and I came to Japan in 2018 October as a master's student in Sozo lab. I just graduated from there in the last month, actually September. Actually, and I started to how to say for job few months ago, and fortunately got a job at Cinnamon AI company. So basically, they work with image vision technologies, NLP, these types of stuffs. So that's really amazing. I just passed around 2 months this company and learned a lot. So for me, actually, it was not so much problematic because the environment is English speaking environment. So yeah, I was very much fortunate in this case. And the techniques that I learned during my master's program, I mean, to say analysis of time series data, and also learning something about let's say image recognition or image vision, this types of technologies using some of the deep learning networks, neural networks. So these stuffs actually helped me a lot during the interview process, or even now. So I'm really grateful to my sensei and all others who have helped me to learn a lot of things.
Thank you, thank you. So Sozo, do you have any comment on internship issues, or because now remotely people can work for different projects regarding this? Number one. Number two, that you have lots of, I mean, a good number of excellent data sets and rare data sets is related to healthcare, nursing, and hospital cases. But you have training data available in some cases, but test data are not available even after the competition. So if someone wants to improve their methods and do better, they can't. So especially, I mean, for the nursing care, two teams, one team got second prize and another team got third prize at the UBComp at your challenge. So they are willing to do better, I mean, further work, and they did something. But so that's why give us some more possibilities so that we can explore on your data sets and go for further collaborations. Thank you.
Yeah, we can open. We are open for the collaboration. So, yeah, the data set for the competition was just intentionally hidden for the test data, basically, just for the fair challenges. But after the challenge, we can open the data set, test data, and also, even for the further data set, we can also share if we do some collaboration or something. So, yeah, feel free to contact us with us if you have any interest.
All right. So anyone, any more question? Okay, I don't think that there are any more questions at this moment because your presentation was very delightful, easy to go through, and lots of examples. So thank you so much. So we'd like to thank Professor Sozo Inoue for his excellent talk and lots of ideas. And he's very cooperative. So if anyone wants to do something, then you can knock, but definitely we remain busy. So do some homework before you ask anything so that it becomes easier. So with that, I thank Sozo for his time for us and a nice discussion. And next year in November 2021, we'll organize a third international conference on activity and behavior computing, ABC. It was held this year. This year we organized in Japan, and last year it was in USA, Washington State University and Eastern Washington University on that campus. So we welcome you all and keep in touch with our website so that you can check the news of the conference. You can search as well, activity and behavior computing. And next, with that, I would like to welcome you for the next webinar. The keynote speaker is Professor M.S. Kamal. He is working on intelligent transport systems and future road transportations, smart car at Gunma University, Japan. And he worked at Toyota R&D and few other places, and he has excellent experience on that. So he will deliver the presentation, and definitely the time is different. You can check that next Friday, 30th October, Japan time 11 p.m. and Bangladesh time 8 p.m. and EST 10 a.m. on the same day, and the URL for the presentation, registration